All right, welcome back. I am absolutely thrilled you're joining me for another deep dive today. We're looking at something we all interact with, probably on a daily basis, but let's be honest, we rarely stop to actually think about it. In this explainer, we're going to decode the brilliant engineering hiding in plain sight, right inside our own kitchens. We're talking about the tools that keep us safe from one of the most fundamental forces in cooking, heat. So grab your mental notepads because we're about to break down the mechanics of kitchen safety in a totally new way. Okay, let's dive right into this. Picture this scenario. You've just steamed a beautiful bowl of rice, or maybe you're pulling a hot metal plate out of a steamer basket or an oven. The vessel is literally scalding hot, and here's the kicker, it doesn't have its own built-in handles. It is a universal, everyday hazard. So how exactly do we safely move it? Throughout this explainer, we're treating this question as a full-on visual investigation. We're not just looking at kitchen gadgets here. We're looking at real mechanical solutions to a very specific problem.
To do that effectively, here's our roadmap for today. 1. Handling the heat. 2. The vertical lifter. 3. The silicone pinch grip. 4. The horizontal clamp. 5. Comparing the mechanics. And finally, 6. The ultimate safety toolkit.
Section 1. Handling the heat. Let's define the problem.
This right here brilliantly illustrates exactly what we're going to decode. We've got a trio of anti-scald kitchen tools. Now, at first glance, you probably notice they're unified by a matching aesthetic, right? They've got this clean, slate blue and white color palette. But look past the colors for a second. Notice their actual shapes. Each of these three tools has been engineered with a completely different structural approach to solve the exact same problem, moving a hot object. You've got a tall wireframe tool, a compact little semicircle, and a super sturdy pliers-like device. It's honestly a masterclass in varied engineering.
Moving on to Section 2, the vertical lifter, top-down leverage.
To really understand this first tool, we have to grasp the core mechanical concept it uses, which is leverage. Leverage is simply the exertion of force by means of a lever. But notice the specific application here. This isn't just about squeezing, it's about reaching. Because of its really tall design, this tool uses leverage from a top-down angle. It's engineered specifically to reach deep down into a pot, maybe a pressure cooker or a deep steamer, to pull out a flat plate or a shallow bowl from directly above.
Let's play investigator for a second and look at the actual features making this top-down leverage happen. First off, you have that tall, open metal wire frame body. That is totally intentional. It keeps your hand far away from the steam and the heat. Then, at the very top connecting that blue handle is a spring-loaded hinge. If you look closely at the handle, you'll see these ergonomic finger grooves. That is exactly where you apply downward squeezing pressure. And that pressure travels all the way down the wireframe to those zigzag metallic grips at the base, locking securely under the lip of a hot plate. It is distance and leverage working in absolute perfect harmony.
Section 3. The silicone pinch grip. Insulation and friction. Now, what is really fascinating about this next tool is how it completely abandons the concept of mechanical leverage. Seriously, unlike the tall metal wireframe we just looked at, this little gadget relies purely on material properties. Specifically, we're talking about insulation and friction. Insulation is using a material to resist the transfer of heat, basically keeping your skin safe, and friction is using surface texture to stop things from slipping. So instead of complex hinges, this tool just lets the physical properties of the material itself do the heavy lifting.
You can see these concepts perfectly applied in its design. It's got this flexible, semicircular silicone body, so there's your thermal insulation. But look inside its mouth. See those distinct interior horizontal ridges? Boom, that's your friction. This is what we call a direct contact design. It lets you manually grasp the edge of a hot plate using your own natural pinch strength. The silicone protects your fingers from the burn, and the ridges make sure a heavy plate doesn't just slide right out. Oh, and it even features a handy little loop on the side for hanging it up.
Section 4. The horizontal clamp. Mechanical advantage.
All right, the driving concept behind this third tool is mechanical advantage. This is essentially the ratio of the force produced by a machine to the force applied to it by the user. While the vertical lifter used leverage for top-down reach, this tool uses a mechanism to create an incredibly powerful horizontal clamping force. Think of it as a force multiplier. This is exactly what you want when you need a vice-like grip on the lip of a heavy, hot bowl or pan from the side, rather than coming at it from above.
The features on this one just scream robust construction. Notice the solid, thick blue handle. While the vertical lifter had those little finger grooves for a delicate squeeze, this thick handle is meant for a really strong, full-fist grip. Grabbing it engages a heavy-duty metal hinge and spring mechanism, which multiplies your hand strength and transfers it straight down to those flat metallic gripping paddles at the front.
And those flat paddles are engineered to slide right over the lip of a bowl. It's built entirely for a horizontal approach angle.
Section 5. Comparing the mechanics. Let's do a side-by-side analysis.
If we line them all up, this matrix perfectly summarizes the genius of this trio. The vertical lifter uses metal wire and plastic for a top-down grip, relying on leverage and those zigzag teeth. The pinch grip utilizes silicone for a variable grip direction, relying entirely on your own manual strength combined with those friction ridges. And finally, the horizontal clamp uses solid plastic and metal for a side-angle grip, leveraging a mechanical hinge and flat paddles. Each tool is providing a highly specific mechanical solution, dictated entirely by the angle of your approach and the weight of whatever it is you're trying to move.
So the absolutely crucial takeaway here is this distinct division in methodology. On one hand, we have direct contact. The silicone grip represents this really intimate, tactile approach. Your hand is right there at the heat source, relying entirely on your own pinch strength, and you're protected only by the material's thermal insulation. Versus, on the flip side, indirect contact. Both of our metal tools, the lifter and the clamp, rely on an extended mechanical approach. They use structural leverage and physical distance to keep your hands as far away from the heat source as possible. It's literally two radically different philosophies of safety.
Section 6. The Ultimate Safety Toolkit. Form follows function. We started off by noticing that all three of these gadgets share that matching blue and white aesthetic, which kinda hints that they belong together. And, well, after breaking down their mechanics, we can see exactly why. Their distinct structural shapes prove a fundamental engineering truth. There is no single perfect solution to kitchen safety. A deep pot simply requires a different tool than a shallow, heavy plate. Together, they perfectly divide the labor, proving that form truly follows function. To have a complete toolkit, you need varied mechanical advantages.
So I'll leave you with this final thought to ponder. The next time you're in your kitchen, don't just blindly grab a tool out of the drawer. Look at your tools with the eyes of an engineer. When you're facing down the heat, consider your angle of approach, consider the weight of the object, and ask yourself, which mechanical advantage will you reach for? Thank you so much for joining me on this explainer. Keep observing, keep questioning, and I'll catch you in the